We have another example on the board. Please notice that this time we have RLC circuit connected to the DC power supply. What it means? It means that the capacitor is going to behave like an open circuit, right? So you're supposed to realize that the impedance of the capacitor is very large. And if it comes to inductors, you're supposed to be very careful, because this time the resistance of the inductor is given. So, for example, inductor L1 has resistance 12 ohms, L2 has resistance 15 ohms, and inductor L3 has resistance 5 ohms. What does it mean? It means that we're supposed to treat them like regular resistors. So we're going to find Z total first. As we said, capacitor is going to behave like an open circuit, so it means that current is not going to flow into this branch, okay? So basically I'm not going to consider this branch when I'm going to calculate Z total. Okay, so I can say that my circuit is going to look like this right now. I have simply voltage source, I have inductor L1, I have resistor R1, and I have inductor L2 and resistor R2. Okay, so if it comes to the total impedance, I'm going to consider only these four resistances. So we have Z total, or R total you can also call, is equal simply resistance of inductor L1, so I have R L1 plus resistance R1 plus resistance of inductor L2 plus resistance R2. Okay, I simply add all these four resistances. So let's plug in the numbers. RL1 is equal 12 ohms. So I have 12 ohms plus R1, which is equal 100 ohms, plus RL2, which is equal 15 ohms, plus R2, which is equal 120 ohms, equals 247 ohms. This is the total impedance, or you can call also resistance, of this circuit. Next, we're supposed to find the total current. In order to find total current, I'm going to use Ohm's law. So I have I total is equal voltage source over Z total. Okay, so I have a voltage source equals 30 volts, is given over here, over Z total, which is equal 247 ohms. This is equal 121 milliamps. And this is the current which goes through these four components. So if you will try to find the current which goes through inductor L2, you're supposed to realize that this is the same current, right, which goes through every single component. This is nothing else, just I total. So I L2 is equal I total. And this is equal 121 milliamps. Why again? Because this is series circuit. In series circuit, current is the same at every single component. So next, we're supposed to find IL3. Okay, the current which goes through this inductor. We said that capacitor, in this case, behaves like an open circuit. So if there is open circuit, there is no current flowing in this branch. So there is no current going through the resistor R3, and there is no current going through inductor L3. That's why I'm supposed to write that IL3 is equal 0 amps. Okay. Next, we're supposed to find VAC, voltage between point A and point C. You're supposed to realize that the whole wire, okay, whole this line is considered as point C. So I can also say this is my point C. This is nothing else, just the ground. So voltage VAC is the voltage across voltage source. Okay? So I'm supposed to say that this is equal to my voltage source. But let's do everything step by step. We're supposed to find first VA. Okay? VA is the voltage between this point and ground. One more time. So, as I said, VA is equal voltage source. And is equal 30 volts. Next, in order to find voltage B, right, voltage at point B, this is my point B, and this is my ground. I'm supposed to find voltage across these two components. In order to do so, I'm going to use voltage division law. Okay, so what I'm going to do, I'm going to simply take voltage source and multiply by the sum of components R2 and L2. Okay, so I have R2, but remember you cannot add impedance, you're supposed to add the resistance of the inductor. So I have RL2 over Z total. Okay, one more time. Voltage source times the total resistance of these two components divided by total resistance is going to give me voltage at this point. Okay, so I have voltage source equals 30 volts times, and I have R2 equals 120 ohms plus RL2, which is equal 15 ohms, close parenthesis, over Z total, which is equal 247 ohms. Everything is equal 16.39 volts. Okay, if you are going to use the calculator, you're supposed to make sure that you are going to put the parentheses in the right places. Okay, this is very important. So this is my voltage B. Voltage C is simply 0 volts. Why? Because point C is connected to ground. Ground is basically the reference point, and in this case is equal 0 volts. Okay, ground is 0 volts. So next we're supposed to find voltage D. Voltage at point D. Because capacitor behaves like an open circuit, okay, you're supposed to realize that voltage at this point is going to be equal to the voltage VB. Okay, why? Because voltage, the highest voltage is going to always concentrate across the highest impedance in the circuit. So capacitor having the largest impedance, because it behaves like an open circuit, it means that it has extremely high impedance, is going to concentrate across itself the maximum voltage, and the maximum voltage in this branch is simply voltage VB, because the sum of these voltages is supposed to give me voltage VB, the voltage which is going to appear across these two components. Okay, keep in mind this voltage has to be equal to this voltage plus this voltage plus this voltage, because there is no current, there is no voltage across this component, there is no current, there is no voltage across inductor also. So it means that the highest voltage, I mean the maximum voltage, is going to appear across the capacitor. So it means that VD is equal to VB, and this is equal 16.39 volts. Okay, this is my VD. Now, if you want to find VAC, VAC is equal VA minus VC, where VA is equal 30 volts, VC is equal 0 volts, this is equal 30 volts. If you want to find VDC, let me write over here, VDC is equal VD minus VC, where VD we found is equal 16.39 volts, 16.39 volts minus VC, which is equal 0 volts. This is equal 16.39 volts. And if you want to find VBA, this is voltage VB minus VA, where VB we found is equal 16.39 volts minus VA, which is equal 30 volts. This is equal negative 13.61 volts. Okay, so we found impedance, we found all currents, all voltages, so we can say that the problem is solved.